So I dah start record. So tadi kita, while waiting for our class untuk start, kita dah tengok cat memes kan. So the first thing yang kita akan tengok, kita tengok kucing, kita tengok anjing pula. Okay, so we will learn about chemical bonding today. So I would like to ask this cute doggies untuk tunjuk how actually a general idea of chemical bonding. So tengok
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Okay, based on the video, you guys should be an expert at chemical. Okay, based on the video, you guys should be an expert at chemical bonding now, okay? Because it is perfectly explained by our cute two friends. Okay, so now kita akan masuk on the my presentation lah. So okay. So we are getting into chapter 4, chemical bonding. So everyone boleh nampak kan? Okay, good. If anything, any question, terus tanya because saya tak nampak korang. Sekejap. Alright. So chemical bonding. Alright. So this is pretty much yang actual formula lah. Contoh yang macam korang buat hari tu, contohlah CH2 CH2 3 CH3 so this is propane. Okay, actually bentuk yang kalau kita tengok dia punya molecular structure is like this, and we will see why it is bent like this, and we have multiple ways in representing a molecular formula. So okay, let's see apa yang kita perlu belajar. So the main thing yang you guys akan belajar lukis. So better if ada what's it called, ada paper and calculator as well. Oh my god, calculator. Oh tak apalah, I tertinggal calculator, tak apa. So we akan represent a bonding using Lewis dot symbol, and kita akan tengok the octet rules and how atoms obtain octet configuration, and then kita akan describe this three bonds. Kita akan tengok where tadi the two anjing dah describe ionic and covalent lah, and also polar covalent bond. Untuk dative ni nanti is an extra, kita akan belajar, and then kita akan draw the Lewis structure. This is the one yang ada a bit of calculation, and then comparing bond length is usually question dia akan tanya between single bond, contoh single bond, and then double bond, and triple bond. Itu type of question yang akan tanya lah. And then formal charge and most plausible Lewis structure. So plausible, okay. Apa maksud plausible ni? Ini bukan salah ejaan Ini actual ayat. So plausible is the most possible and stable. Mana tadi pergi? Dah hilang dah. Here, okay. Okay, plausible is the most possible and stable. Okay. Kalau dalam nature, kalau you guys tengok tu, it is most likely akan bentuk macam that Lewis structure lah, because there's many options when kita nak letak electrons, kita akan tengok kat mana. And then kita also ada exception, so like anomalous cases lah. Kenapa those few atoms that follow the octet rules. Okay, kita akan tengok apa tu semua, octet rules, Lewis dot symbol. Okay, let's get into the topics. So, chemical bond is a force that hold two atoms together. So, it makes sense. And highlight on valence electron. So, untuk bond, untuk any bonding, we only look on valence electron. Okay, valence electron only. So, it is very important for you to recognize which one is the valence electron. Okay. Inner electrons play no roles whatsoever in the bonding. Okay, so let's look at Lewis symbol. So this is an example of Lewis symbol of the formation of water, ammonia, and methane. Okay, how water form, and this little dot merah ni is the representation of dia punya valence electron. Okay, so Lewis symbol consists of the atom symbol. So in this case it's sodium and chloride, and we use dots or cross to represent the valence electron. Okay, untuk you, bila you jawab, it is you boleh pilih kalau you nak guna bulat ataupun X. So X ni is a very small X lah. So contoh untuk hydrogen, letak the small X. Okay, this represent dia punya valence electron. Okay, so actually this is sodium and chloride. Diorang boleh react together to produce you punya salt. Okay, garam yang you guys guna untuk masak tu. Okay, now we dah tahu Lewis symbol. Alright, so nanti kita tengok. Okay, untuk sodium ni, contoh sodium untuk Lewis symbol, doesn't matter kalau you letak the electron valence dekat sini ke, dekat sini or dekat sini, sama, betul je. It's just that kalau if you notice, we have actually 4 tempat nak letak electrons. Every elements we have 4 tempat. So we have atas and bawah, kiri and kanan. Okay, so usually untuk setiap ni kita hanya letak 2 sahaja. So 2 kat atas, 2 kat tepi, 2 kat bawah, 2 dekat kiri. Hence why if you remember tadi saya cakap pasal octet rules. So if kalau penuh, contohlah kalau penuh, the total is 8. So that's where kita dapat octet rule. Okay, so this is an example of Lewis symbol. So if you see, so sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. And this kita hanya tulis valence electron dia sahaja kan, macam saya cakap tadi. So this is an example of how we represent those atoms. Okay, what is an octet rules? Okay, so hilang pula. So octet rules stated that atom will lose or gain or share electron to obtain 8 valence electron. So if you remember hari tu saya cakap kenapa dia lebih senang untuk jadi plus 2 ke or minus 2 ke, sebab hari tu dia nak completekan dia punya shell kan. So it is the same thing macam hari tu kita belajar. Okay, the reason is it is to achieve noble gas configuration, which is penuh ni. Maksudnya this is what octet rules lah. So every atom cita-cita dia bila dia dah besar is dia nak have a complete set of electron, which is dia nak fully ada 8 elektron, ada 8 valence electron. It means that dia dah tercapai lah cita-cita dia. So why? Sebab when dia ada completely 8 elektron, it is stable. Okay, so why? Kenapa kita tahu dia ada 8 valence electron, it is stable? Okay, if you see you punya periodic table, contohnya dalam group dalam you guys punya tutorial ada ke yang the one I give you, if you see the very far right groups, okay, group 18 paling hujung paling kanan, okay, those are called noble gas because diorang ada 8 valence electron, okay, kecuali helium. Helium is special case, it is duplet. Okay, helium sahaja is duplet. It means that ada 2 valence electron. Untuk yang lain, group 18, so group 18, semua ada 8 valence electron, which is octet. Yeah, octet configuration. So these gases are called noble gas. Okay, orang-orang kayangan, orang-orang atasan. Okay, because diorang ni is very stable and diorang tak nak react with any other atoms. Okay, alamak hilang, tak nampak. Okay, so helium obey duplet and other obey octet rules. Okay, helium is a very special case. Okay, so if you remember, kebanyakan helium, okay, where you guys jumpa helium is dalam balloons. Okay, balloons dekat fun fair ataupun jom heboh. And other thing is orang guna untuk orang isap, and then suara dia bertukar jadi halus kan. Okay, there's one case where the vendors use hydrogen instead of helium. Okay, so the question is, kenapa kita kalau boleh dia nak guna helium? Sebab helium is a noble gas and dia tak nak react with any other atom. So it's actually very safe nak guna helium. Tapi kalau lah kita tukar guna hydrogen, so this penjual balon ni dia nak murah sikit, dia guna hydrogen. Hydrogen is very flammable. Liquid hydrogen is also used as a rocket fuel. Okay, so bila dia tukar guna hydrogen is very flammable. Hari panas dekat pesta, so terbakar. So that is dekat Putrajaya ni. So bila ni? Kalau saya tahu 2019 berapa tahun lalu lah. Sekarang dah 2000. Saya rasa macam tahun lepas je 2019. Dah lama lah. Okay, you guys boleh go and baca. So that's why every other atom want to be noble. Dia orang tak nak, kalau boleh tak nak dah react dengan any other element. Sebab dia orang nak have a complete octet rules. Okay, a few ways untuk atom-atom ni capai cita-cita dia orang. Okay, first is transferring electron. So maksudnya the electron form sodium. Okay, this sodium dia bagi je elektron dia ke klorin. Okay, so sodium ni dah tak ada valence electron and chlorine dapat a full valence electron. So dia happy. This one happy. Sodium pun is actually happy sebab dia punya inner shell dah penuh. Okay, so ataupun diorang share electron, so which is covalent bond, macam yang anjing tadi cerita. You have ionic and covalent. Okay, the difference between ionic and covalence. Okay, ionic diorang bagi, so bagi terus 100% terus bagi hak milik elektron tu kepada another person, while untuk covalent bonding, diorang share. So if you see, kalau diorang share, okay, all of these electrons are not only for oxygen, it's only shared by the hydrogen. So diorang share. Okay. So let's see the first example of ionic. Also some books, okay, some older books call it electrovalent bond. Okay, which is maksudnya electro ni is anything yang related with electrons, and valent means valent electron, right? So berkaitan dengan electron valence punya bond. Okay, ionic. So untuk ionic always ada one is always akan ada positive and the other one is always akan ada negative. 100%, 110% of the time. Okay, but tak semestinya plus je atau minus je, maybe ada 2 plus or 3 plus, doesn't matter. So one example is the formation of your salt, okay, garam yang you guys guna untuk makan. Okay, so formation of salt, sodium. Okay, sodium kalau you guys tengok, it is group 1 and it is at period 3. So it has 11 electrons. 11 electrons. Okay, kalau kita susun 1s2, 2s2, 2p6, 3s2. Okay, untuk dia ada complete shell, okay, lagi senang kalau dia nak buang terus ini, buang, and you got a complete octet. Nampak tak? 2, okay, kita tengok dia punya principal quantum number, and 6 tambah 2, 8. So 8 elektron. Dia dah complete 8 elektron. So it is easier untuk dia buang this 1 electron daripada 3s to form sodium plus ion. And it is the same as chlorine. Kalau you guys susun chlorine ada 17 elektron. 17 elektron. 1s2, 2s2, 2p6, 3s2, 3p5. Okay, untuk completekan 8 elektron, you only need to add just 1 electron here, kan? So it is easier for chlorine untuk accept electron, and untung untuk chlorine, sodium is readily available untuk give an electron. So sodium give out electrons. So these electrons diambil oleh chlorine. Okay, chlorine ambil, which is this electron, to form a chlorine minus. So dia dah complete. Okay, so this is an animation where how it forms. Okay, so the electron from sodium dapatkan chlorine. Bila dia dah bagi, diorang are charged, so diorang are attracted to each other. Plus are attracted to minus. Okay, so this is another example. Contohnya CaCl2. So if you look, you guys tengok, calcium usually ada 2 plus and chlorine is minus. Okay, kalau you guys sekolah menengah dulu buat darab silang kan, so you dapat calcium 2, apa benda calcium 2? Calcium chloride. Okay, calcium chloride. You guys always thought that it is because of dia punya charge kan? Okay, the reason is calcium, kalau if you guys tengok, dia ada 2 available electrons yang untuk freely to give. So, dia takkanlah nak bagi kat satu je chlorine, sebab dia dah bagi satu, ada lagi satu extra. That's why calcium, dia bagi 2 electrons, 1 to each of the chlorine. So that's why it is calcium 2 chlorine. Okay. So, by Lewis structure, show the ionic bond formed in the compound below. Okay, so let's see. I'll give you example of C lah. You guys boleh try untuk KF dengan barium oxide. So let's do C. So sodium and oxygen. So kalau you guys, untuk apa-apa yang ada oxygen, most likely it is ionic lah, sebab oxygen is usually 2 minus. Okay, and sodium is plus. Okay, kalau you guys nak tahu it is plus ke 2 minus, buat balik dia punya electronic configuration and you guys boleh cari dia punya charge. So cara nak show the ionic bond form, caranya nak jawab, contoh soalan jawapan C is to draw the Lewis structure. So let's draw the Lewis structure of sodium. So sodium ada berapa valence electron? Kalau one way untuk lagi cepat nak tahu berapa valence electron yang dia ada, tengok group 1. So it means dia ada 1 valence electron. Saya nak guna color lain lah. Color lain cantik sikit. So dekat mana I nak tulis the valence electron? Saya nak tulis, kalau boleh, untuk senang, lukiskan dekat yang bertentangan dengan apa yang you nak, apa benda saya nak cakap, apa yang you nak letak lah. So, kalau if you tengok, untuk oksigen, so oksigen dia adalah group 16. Group 16 ada berapa electron valence? Group 16 ada berapa electron valence? Orang tolong cakap.
6.
6.
6.
6. Oh, 6. So, macam mana kita nak letak?
6.
So, cara nak letak, which is 1. Dia letak keliling dulu. 2, 3, 4, 5, 6. Like that. Okay? So, if you guys tengok, oksigen usually dia akan suka ambil 2 elektron. So, cara nak tulis is so you need berapa? So, you need 2 elektron. Sodium only have 1. So, kita perlukan 2 sodium lah untuk gabung and dapat 2 sodium. Okay. Untuk ionic, it is crucial untuk you guys buat bracket and dia punya charge. So sodium dah jadi plus sebab dia dah give all of dia punya electrons. So we have 2 sodium sebab kita perlukan 2 kan. And also oxygen. Okay. Oxygen dia dah ada complete kan tadi sebab dia dah ambil electrons from the sodium. So lukiskan yang dah complete, which is the octet, and charge dia. This is the correct way untuk jawab. Okay. Kalau you tak ada bracket, salah. You tak ada charge, salah. You tak letak electron valence here pun salah. Because this is the way untuk jawab Lewis structure. Any question so far? Before kita move on.
Sir,
Yes.
yang sodium tu tak perlu lukis kah? Dia punya valence electron.
Okay. Kenapa kita tak perlu lukis? Sebab the sodium dah bagikan ia punya electrons dekat oksigen tu. And another sodium also dah bagi electrons dia dekat oksigen. And sodium, kalau you guys remember, every bond kita only look on valence electron. So bila valence electron dia dah habis, sodium actually dah tinggal dengan 1s2, 2s2, 2p6, which is inner electrons, and 3s1. Saya guna color lain lah. So it is 3s1. Okay, this electron yang dia donate kepada oksigen. Okay, and this is dia punya valence electron. Okay, untuk Lewis structure kita only letak dots for valence electron. Inner electrons kita tak tulis pun. So kita biarkan. Okay, boleh ke?
Sir,
Yes.
untuk oksigen after ultraviolet dia negatif 2 kan?
Oh yeah, negative 2. Thank you for pointing it out. It is 2 negative. Sebab dia dapat 2 electrons. Thank you. So, any more questions?
Sir,
Yep.
kalau lukiskan kita tidak perlu guna X and cross and dot kah?
Oh, boleh juga. You nak lukis guna cross ataupun bulat, boleh. Okay. So, untuk ionic, Untuk ionic, it is not that crucial lah, because elektron tu dibagi terus. Okay, so you lukis bulat pun tak apa. Untuk covalent, saya akan tunjuk why it is crucial untuk satu guna X, untuk satu guna bulat. So this one doesn't matter you nak guna bulat atau X. It just that one thing is janganlah campur macam ni. Is untuk oksigen ada 6 dia punya valence electron, buat bulat suka hati je, suka hati. And then ni, because if you draw it like this, dia dah bermaksud lain. Dia dah bermaksud that X and bulat dots are coming from different electrons. Okay, so kalau you dah buat bulat, buatlah bulat semua. And it is okay untuk you guna sodium untuk you buat X, and nanti untuk this you buat macam ni. Okay, it is also correct. It's just that kalau one atom tu you guna bulat, that atom you only guna bulat. Kalau that one atom you guna X, dia only guna X. Okay, so let's see on covalent bonding. So how covalent bonding actually works? So if you see, it is sharing of an electrons. Okay, so we have 3 type of covalent bonding. Covalent bonding is the bonding yang banyak kita tengok lah. Okay, so we have single, double and triple bond. Okay, single maksudnya it is kita share 2 electrons. Okay, and untuk double kita share 4 electron, and untuk triple bond kita share 6 bonds. Okay, it means that in one bond, okay, this is how we represent a bond. Okay, ada 2 electrons. So kalau lah dia double bond, maksudnya ada 2 garis. So 2 darab 2, we have 4 electrons, and so on and so forth lah. So we have 6 electron. Okay, these bonds also have nama. Okay, untuk single bond, okay, single bond kita panggil dia nama. Okay, mak ayah dia bagi dia nama, bagi dia nama Encik Sigma. So Sigma is a dia punya simbol is like this. So it's like bulat tapi ada rambut sikit, macam 6 kena penyek. Macam tu. And untuk single ke, double ke, triple ke, always ada sigma. The very first bond is always sigma bond. Okay. The second bond, contohlah the carbon tu ada 2 bond. The second bond is no longer a sigma. We call it a pi bond. It is a pi bond. Okay. And contoh kalau triple bond, okay, this triple bond, you have 1 sigma bond, and we have the second one is pi bond. The third one is also a pi bond. So maksudnya kalau triple bond, we have 1 sigma and we have 2 pi bond. Okay. Kenapa we have sigma and pi? It is actually the orientation. Okay. Okay, you guys kalau boleh okay, untuk single bond. Okay, kalau you guys remember orbital. Untuk sigma, single bond, overlap dia macam ni lah. Dia macam ni overlap. That's why it makes a bond. Untuk double bond, the overlap is like this. Okay. Nanti kita akan belajar further on sigma and pi bond. So this is called, this is sigma. The overlap macam ni. Sigma bond, and overlap yang kalau you guys nampak is actually jauh, tapi is actually overlap each other. So this kind is called pi bond. Okay, pi bond. And kalau if you remember, kita ada 3D space kan. We also have orbitals yang bentuk sini like this, bentuk macam ni. That one is your second pi bond. So apa color saya nak guna? Purple. Purple dah ada. Orange lah. So this is the second pi bond. Pi bond yang kedua. So that's a general idea of bonding, of covalent bonding, sharing. Okay. question usually akan tanya benda ni untuk maybe the next UPS akan tanya benda ni lah. Maybe or maybe not. I'm not sure. Okay. Bond type and bond length. Okay. Untuk single bond, it is the longest bond. Kalau you guys ingat, this is in nanometer. The longest bond. Sebab they only have one ikatan. Okay. Imagine carbon and carbon, you have one rubber band. Okay. You have one rubber band. You ikat rubber band keliling dia. So as you can imagine, you can stretch it quite far lah. It's only one rubber band. Okay. But the more bonds you ada, okay, you have one rubber band, and then you add another rubber band. So kalau you tengok, is a bit harder untuk tarik those from each other. So the second rubber band make it the bond length shorter. So lagi banyak bond, lagi dekat lah the atom. Okay, the atom makin dekat with each other. Okay, so also makes sense, lagi banyak bond, it is lagi strongest lah. Sikit bond, weakest, right? So bond length ni, usually dia orang tak tanya the exact bond length because every atoms are different bond length. You just know the general idea of pendek and panjang bond and strong and weak bond. Okay. So this is example kalau ditanya Lewis structure of covalent bonding. So this is when kita guna X dengan 0, X dengan dot. So the formation of hydrogen gas. So hydrogen gas, both are one valence electrons. Okay. So each of the valence electron is shared with each other. So and then kita nak lukis dia punya Lewis structure is like this, and this is dia punya, ini pun diterima. Okay, where kita represent two shared electron as a bond. Okay, and this is the formation of double bonds of oxygen gas oxygen yang you guys bernafas hari-hari. So actually kalau you guys tengok, ini share dengan ini, okay, they all share with each other, and then we also have another one where they share. Okay, why it actually do this? Sebab if you remember, every single atom want to be octet ataupun duplet. Okay, so let's see on hydrogen. Let's see hydrogen dekat atas ni. So hydrogen, so every atoms, they only happy kalau they duplet or octet. So hydrogen, let's see on hydrogen. So we have hydrogen A and hydrogen B. So hydrogen A, cukup tak 2 elektron? 1, 2. Cukup, dia happy, senang. Okay, at hydrogen B, they also share the 2 electron. So dia pun happy, dia senang. Okay, let's look on oxygen pula. Okay, oxygen is, so just a general idea, only hydrogen and helium sahaja yang ada duplet lah, yang suka jadi duplet. Yang lain semua nak jadi octet. Okay, so oxygen dia nak jadi octet, dia perlukan 8 electron valence baru dia happy. So let's look on oxygen A and oxygen B. Oxygen A, dia ada 1, 2, 3, 4, 5, 6, 7, 8. Right, they happy. And oxygen B pun ada 1, 2, 3, 4, 5, 6, 7, 8. Dia pun happy. Okay, untuk yang dekat tengah ni, it means, okay, in between, it means that is not only electrons A, untuk oxygen A is also shared by electron B. So maksudnya it is elektron yang dikongsi. So this is an example of electrons yang kita share untuk buat nitrogen gas. Okay, nitrogen gas boleh form triple bonds. How do you form triple bonds? Okay, you guys tengok, untuk nitrogen cukup tak 8? 1, 2, 3, 4, 5, 6, 7, 8. Nice, dia dah cukup. This one, 1, 2, 3, 4, 5, 6, 7, 8. Ini pun dah cukup. So that's how kita represent. Kita can also represent like this lah. Sebab 2 electron is consider one bond, another bond, and another bond. So we can, this one is also accepted. Because kalau if you think nanti nak jawab periksa, untuk buat X dengan titik is quite messy lah kan, panjang-panjang. Okay, so this, how do you know mana satu ionic, mana satu covalent bond? Okay, so untuk ionic, okay, we look on dia punya electronegativity values. So if you remember untuk chapter 3 hari tu kita ada belajar pasal electronegativity is the tendency of an atom untuk tarik electrons ke diri dia. Okay, lagi tinggi value electronegativity, so electronegativity, okay, lagi tinggi value electronegativity, lagi kuatlah dia punya desire untuk tarik elektron ke diri dia. So that's why lagi senang dia nak form ionic bonds. While covalent bond is usually anything yang lower than 1.7. Okay, later on, I'm not sure whether I dah bagi dekat you or not. If you can look at my camera, this is the electronegativity of elements punya periodic table. So it has all of the values, and also don't worry, the values will be given kat you dalam exam pun akan diberi in a form of electronegativity tables. Okay, untuk ionic bond, so untuk determine dia it is ionic bond, the difference between contoh sodium and chlorine punya electronegativity must be equal or more than 2.0 is a general idea lah. Okay, contoh lah. So I'll give it chlorine. Chlorine is, dia punya electronegativity value is 3.16 and sodium is 0.93. That is the value. So if you tolak, it is already more than 2.0. So they can form ionic bond. Kalau the value is less, okay, less than 2.0, so less than 1.7 lah actually, it probably akan form covalent bonds. Okay, this is the other bond yang anjing tadi tak ajar. Anjing tadi ajar sampai covalent bond je. So what is dative bond? Dative bond is when only one atom provide both electrons in a shared pairs. Okay, also known as coordinate bond. So buku lama sometimes call it coordinate bonds. Okay, but we akan call dative lah. Okay, this is an example of an acid, of an hydroxide acid. So it is when water, okay, water, they react dengan H+, which is an acid, untuk make an acidic water. So what happen is, kalau you tengok, the oxygen, dia sharekan the 2 electrons kepada hydrogen. Okay, so hydrogen jadilah duplet. So hydrogen jadi duplet. So dia very happy. Wow, happy hydrogen. So cara nak tulis dia punya Lewis structure is like this. If you look closely, this is a straight, meaning a bond. So ada 2 electron shared, right? This is also shared. And cara nak tunjuk dative bond is by using an arrow. It means that oxygen give to the hydrogen. Okay, the arrow means, okay, direction of the arrow means that dia datang daripada siapa elektron tu kepada siapa. Okay, dia oxygen tak bagi 1, dia bagi 2. Okay, so it is an arrow. Okay, this is the step of drawing Lewis structure. This is the one that I want you guys to take out a paper and follow me through. Okay, kita tak lukis the structure of Mr. Lewis ni. Okay, we have step by step. Okay, don't worry, memang banyak step, but this is very easy. Okay, first we need to count the valence electron. Why? Because in any bonding, only valence electron yang involved. Okay, so kita kira valence electron. Macam mana nak dapat valence electron? Form P. Macam mana nak aja periodic tables? Okay, I dah lupa cara nak aja periodic tables. So you know periodic tables lah. So look on the periodic tables, look on the groups. Okay, group is dari atas ke bawah. Okay, you tengok group dia berapa, you cari dia punya valence electron. Okay, dah done, you have valence electron. You tengok dia ada positive or negative charge tak? Okay, we know that negative tambah. Okay, untuk positif kita tolak elektron lah. Tengok based on dia punya charge. And then kita akan decide central atom. Okay, which is the most electropositive element. Okay, tengok you punya electronegativity punya tables and tengok which one is the most electronegative, that one yang akan duduk tengah. So most likely, okay, most likely kalau ada carbon, most likely akan ada carbon duduk tengah. Okay, hydrogen very rarely untuk duduk tengah. Hydrogen pretty much all the time dia akan duduk di tepi. Okay, and then complete the octet. So dekat tengah, okay, dekat luar dulu you complete kan untuk octet, kecuali hydrogen sebab dia only have 2 electrons, and then dah keliling dah habis, baru you isi dekat tengah. Okay, so untuk this I will show you step by step example lah, because yes I cerita but it is a bit vague kan. So let's take this step into example. So the first example kita nak buat is hydrogen fluoride. See? Okay, so hydrogen fluoride, first kita count dia punya valence electron. Alright, so hydrogen have 1 valence electron. Okay, untuk this we always jawab like this lah. So first valence electron, so we have 1 and 7 untuk fluorine, and kita totalkan the valence electron. So kita ada 8 valence electron. Okay, make sense. So now second step, kita decide the central atom. So central atom is the atom yang more electropositive. Okay, fluorine is the most electronegative atom. So fluorine memang kalau boleh memang takkan duduk tengah lah. So hydrogen is more electropositive than fluorine. Thus hydrogen is the central atom. And then second step is kita completekan octet for terminal atom. So kita completekan. So 1, 2, 3, 4, 5, 6. Okay, that's complete. So this bond is signify dia punya bond lah between hydrogen and fluorine. So kalau and then you kira balik, cukup tak total of 8 valence electron ni? Dah habis ke you guna? So 1, 2, 3, 4, 5, 6, 7, 8. So dah habis valence electron, tak perlu dah letak dekat central atom ni. So this is your final Lewis structure for fluoride acid lah. So the Lewis structure is complete. Look on the second example of methane. Methane ni is gas yang bau busuk bila you kentut. Okay, gas kentut awak. Okay, so let's count the valence electron. So let's count carbon. Carbon is group berapa ni? 18, 16, 17, 16, 15. Group 14. So group 14 maksudnya it is ada 4 valence electron. Okay, and hydrogen is group 1, dia ada 1 valence electron, tapi remember we have 4, kita ada 4 hydrogen, so darab dengan 4, so the total is 8 electrons. So the second step, kita decide the central atom, which is should be carbon, because carbon is more, even though hydrogen is more electropositive. Okay, kita always letak hydrogen dekat luar sebab hydrogen, kalau you remember, is only paling tinggi pun is duplet, which is dia ada 2 electrons. Okay, kalaulah kita letak hydrogen di tengah, okay, dia boleh ada 2 elektron saja. Bolehkah kita nak sambung ke elektron lain? Because one bond dah ada 2 electrons, so kita tak boleh nak buat another bond. Sebab dah lebih. So hydrogen usually akan duduk tepi. So kita dah decide the central atom, and then kita guna this 8 elektron untuk fill up atoms yang dekat luar dahulu. So complete kan. So you letak 2 sini, 2. Since dia ada 2, which is kita boleh buat dia sebagai bond, right? So kita jadikan dia sebagai bond. So kita jadikan bond. So kita kira balik, cukup tak? Dah berapa elektron kita guna? 1, 2, 3, 4, 5, 6, 7, 8. So kita dah guna 8. Okay, so it means that kita dah guna all of the valence electron. So dah tak perlu dah nak letak. So the Lewis structure is complete. Okay, let me know kalau if I cepat ke apa ke, because I want to see CH3Cl3. Okay, the first step, always find the valence electron. Carbon ada 4, hydrogen ada 1, chlorine ada 7, but chlorine ada 3 kan. So kita ada 3 chlorine. So dah ada 3. So total kita ada 26 electron. Oh my god, ada banyak elektron. Macam mana kita nak susun? Okay, the second step is to pick up and the most electropositive atoms. So I'll give you the values. So carbon is 2.55, hydrogen is 2.20, and chlorine is 3.16. Dia punya electronegativity values. Don't worry, this value will be given dekat you. Okay, remember tadi kita tak even though hydrogen is the most electropositive, tapi kita tak letak tengah. Kenapa? Sebab dia only can accommodate 2 electron. Thus nanti kita buat, kita tak boleh sambung. Okay, goes untuk any molecules, kalau boleh dia nak bercabang macam ni. Dia nak bercabang dalam bentuk macam ni. Okay, kalau boleh molecules or atom dia tak selesa nak duduk panjang-panjang. So nak letak hydrogen and then carbon and then maybe another carbon. Tak suka. Kalau boleh dia nak bercambang macam pokok. Okay, macam branch dekat pokok. Okay, so it is, kita dah decide carbon lah paling rendah except hydrogen, right? Because chlorine is 3.19. So you lukis carbon dekat tengah, and then you nak letak yang lain. Okay, ada berapa atoms, you just letak je keliling. Letak hydrogen, chlorine. Doesn't matter macam mana you nak susun. You letak chlorine sini, chlorine, hydrogen, doesn't matter. You just susun dekat keliling dia. But remember, always susun, because kita guna only 4 tempat. So we have atas and bawah, kiri and kanan. So we have up and down, left and right. Itu je. We have 4, right? Later on there ada more, but generally kita akan guna 4. Okay, kita dah decide the central atom. So lepas kita dah decide the central atom, okay, kita draw bonds. Kita connect every single yang keliling tu ke the central atom. Connect. Okay, by connecting, lepas you dah connect, so let me show you. Mana so eraser. So the first thing is you tak isi kat luar dulu, you connectkan dulu. So you dah connectkan pen. So when you dah connectkan, so it means that you guna berapa electrons. So satu bond is 2 electrons. Okay, 2. You dah guna of 8 electrons. So you have 8 electrons dah guna. So 26 tolak 8, 26 tolak 8 should be 18 kan? Kan. 26 tolak 8 should be 18. Okay, and then you use this 18 electron you taburkan ke keliling punya atoms untuk complete dia sebagai octet. Okay, hydrogen dah tak tambah sebab dia only boleh ada 2. So hydrogen dah complete. So you have 18 electrons, you isikan, bagi penuh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18. So you completekan octet into terminal atoms. Okay. Thus, kita dah habis, kita tolak 18, kita dah guna 18 elektron. 0. So the Lewis structure is complete. So basically, you punya kerja is to find the valence electron, create a structure, and then gunakan all of the valence electron. You perlukan guna semua. Okay, tak boleh tinggal satu pun. Semua kena guna. So example here, the final example is CO3 2-. So let's find the valence electron. Carbon has 4 valence electron. Oxygen is group 16 and kita ada 3 oxygen, so 3. And then jangan lupa we also have charges, so 2-. 2- maksudnya dia dah curi 2 electrons, so maksudnya kita kena tambah 2 electrons. So the total is 25. Okay, now you punya kerja is to susun all of this 24 saya cakap 24, sorry 24 electrons. So your job now is to use all of these 24 electrons. Okay, first pick the most electropositive atoms lah. So carbon is 2.55 and oxygen is 3.44. Obviously carbon dekat tengah. Okay, dah lukis carbon dekat tengah. Doesn't matter you nak letak macam ni or you nak letak carbon doesn't matter you nak letak macam mana, up to you, up to your creativity. Jangan sampai macam ni you letak macam ni. Saya cari korang tambah-tambah, korang dah sampai dekat college nanti. The first thing saya suruh korang mandi dalam longkang sini. Okay, the reason why to space it here cantik-cantik, so that when you lukis, when you letak the valence electron, you punya drawing tak semak, tak messy. Okay, so you dah pick the central atom, connect it first. So you connectkan ke central atom. So bila you dah connect to central atom, you dah guna berapa ni? 2, 2, 2, 6. So 24 minus 6, you dapat berapa? 18 elektron kan? Betul tak? Oh, kalau saya punya calculation salah, bagi tahu So you dah guna 6. You ada 8 lagi electrons yang you perlu isi. Tanggungjawab you sebagai seorang pelajar yang bertauliah is to isi this electron. So you ada 18 elektron. So gunalah 18 elektron ni. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 darab 3 is 18, right? Kenapa you kena isi? Sebab you nak make sure everything is complete. Betul ke? 6 tambah 6 tambah 6. 6 darab 6 darab 6, 12 kan? 14. Betul tak? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Betul lah 18. Betul. So 18. Okay, so kalau you guys tengok 18 elektron kita dah guna sebagai lone pair dekat. Okay, sorry, saya tak beritahu apa lone pair tu lagi kan. Lone pair, bila je orang cakap lone pair, maksudnya is pasangan yang kesunyian. Okay, lone pair tu is this. Lone pair is any electrons yang as a pair, which is 2, duduk bersendirian. That is lone pair lah. Apa maksud tu lone pair? Ini masuk lone pair. Contoh example of lone pair, lone pair, lone pair, lone pair. So, kalau if you see this, alright, you have used all of the electron valence. You have 18 dekat keliling oksigen, right? And you also have 6 to make the bond. So you have the total of 24. But the problem now, this carbon tak cukup lagi octet. Okay, how do we know dia tak cukup octet? So look at carbon punya, Allah dah jadi bintang lah. Okay, carbon punya electrons. So dia ada 1, 2, 3, 4, 5, 6. So it has 6 electron, not 8. Dia tak happy. Dia marah. So bila dia mana my cursor ni? Dia hilang ke? Okay. So dia tak happy lah. Dia pun alamak nak buat macam mana? Dia mesti completekan juga 8 elektron. So carbon ni pun jadi jahat. So apa dia buat? Dia curi 2 elektron daripada oksigen. So saya give an example dari sini lah. Okay. But it doesn't matter. Dia also boleh curi dari sini. Also boleh curi dari sini. Doesn't matter. Whichever oxygen the same. So dia curi. So sebabkan dia curi tu, this oxygen, sebabkan dia curi, this carbon ni curi oksigen punya oksigen punya electrons kan. So dia curi 2. Kalau dia curi 2, dia pun dapat just 2 minus lah. But in this, sebabkan semua sama, these 2 minus are shared among the electrons, amongst the atoms. So how we draw it is by putting a bracket. Okay. Untuk ion, we always have brackets and 2 minus. The total charge is 2 minus because, and a simpler words that these 2 minus are delocalized. Okay, because dia boleh dapat daripada oksigen ini, oksigen A, B ataupun C, doesn't matter. Carbon boleh ambil dari mana-mana oksigen to make the double bond. Okay, boleh ke? So how much? So we have a few more. I'm gonna give you an example dulu of formal charge, and then we'll sambung. So this Thursday cuti, okay? Tapi kalau boleh saya nak buat kelas sikit, nak habiskan formal charge. Because formal charge today, I can give you a brief idea dulu. What is formal charge? Charge yang very formal, dia pakai suit and tie. Okay. Formal charge has a formula. Formula ni takkan diberi and you guys kena remember. Okay. What is the formal charge? Okay. Formal charge is only a charge at certain atom. Maksudnya kalau C, H, 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 okay, saya ingatlah H saya. So, formal charge is not the total charge. Bukan total charge. It's the charge of each atom. So, carbon ni apa charge dia, hydrogen ni apa charge dia, hydrogen ni apa charge dia. Like that. Okay. So, formal charge is the number of valence electron. Kita dapat tahu dia punya group. Okay. Contoh carbon is ada 4 valence electron, hydrogen ada 1, chlorine ada 7. As that. Okay, that is the example. Tolak dengan kurungan of lone pair electrons plus dengan half times number of bonding pair electron. The one thing yang a lot of people do mistake is this bracket. This bracket lah. So remember, bond mass is you calculate anything in the bracket first. So number of lone pair, okay, plus half of the number of bonding pair electrons. You dah dapat berapa nilai ni, baru valence electron tolak. Okay, so let's see an example. So calculating the formal charge. So kalau question tu tanya formal charge, okay, it is now to you, you have to label the oxygen. Sebab kalau if you tengok, we have 1 carbon but we have 3 oxygen. So the first thing, label element. So suka hati lah saya nak label A, B, C. Nak label X, Y, Z ataupun Abu, Ali, Ahmad, doesn't matter. Up to you. But it's senang lah antara A, B, C. So untuk carbon, okay, carbon dia punya valence electron is 4, okay, and then minus dengan number of lone pair. Okay, carbon tak ada lone pair, dia tak ada, so 0 lah, plus dengan half of number of bonding pair electron. Kenapa 8? Because dia ada 1, 2, 3, 4, 5, 6, 7, 8. This is the electron that are bonded, are shared. So ada 8. So 4 minus dengan 0 plus half times 8, which is 0. So okay, 0. So let's tengok oxygen A. So oxygen ada 6 electrons. Okay, number of lone pair. Okay, kira dia ada 1, 2, 3, 4. Apa saya cakap ni? 2, 4, 6. So dia ada 6 lone pairs plus dengan half of bonding pairs. So half bonding pairs. So dia ada 1 and 2. So this is the bonding pairs. So you tolak, dia dapat the charge of negative 1. Right? So we do the same for B. Right? And we do this. And now the only difference is C. Okay? Kenapa C dapat kosong? Because valence electron is still the same. But lone pairs, sekarang lone pair dia only ada 4. So 1, 2, 3, 4. And plus of half of bonding pairs. So kita ada 4 elektron yang bonding. So 1, 2, 3, 4. So now you get 0. Okay. One thing untuk you tahu, you punya calculation for the formal charge is correct. Okay. You kira betul is the total charge. Okay, tambah 0, tambah minus 1, tambah minus 1, tambah 0 is equivalent to dia punya total ions charge. Okay, this molecule, dia punya charge should be total, the same. Okay, so that is formal charge. Okay, so next Thursday is cuti, right, hari Malaysia. Okay, so I would like to do a class and I want to make sure you guys bagi tahu, nanti I'll make a poll, you guys bagi tahu lah bila yang you guys free, kita akan sambung. Okay, so everything is clear so far? Okay ke? I want to stop recording and the class kita pun dah habis.